I'm here to talk about introduction to the 4x1 multiplexer. Well, mostly multiplexes for my computer architecture course. So we start with introduction to the 4x1 multiplexer. What is a multiplexer? A multiplexer is a digital switch that selects one input from multiple inputs and forwards it to a single output. 4x1 multiplexers overview. That's inputs. That's 4 data inputs: 1 0, 1 1, 1 2, 1 3. That's also has select lines. That's 2 control inputs. That's S0 and S1. And has output, just a single output. In the circuit diagram overview, that's components in the circuit. We have the AND gates used to enable only one input at a time based on selection lines. We also have the OR gates, combines the output of the data gates to produce the final output. That's working. You also have the working principles. Each AND gate is connected to one data input and a unique combination of select lines. Only one AND gate is active at a time, depending on the values of the S0 and S1. So now, having understood all of this, we move on to the design. So we use an app called Logism. So we'll launch Logism at this point. Then that's what we use to construct our diagrams. So we first take AND gates. We need 4 AND gates. So this is the first one. The second one, we need 4. But let me position myself well so that it will fit. Position my AND gates well so that it will fit very well. And we move on to our third one. We take our third one. And this is our fourth one. Our fourth AND gate. Yes, our fourth AND gate. Then we move on to our OR gate. We take one, we set it up in the diagram equally. Yes. Then we take our NOT gate. We need 2 of that. Our NOT gate, we need 2. And we position them very well so that we can easily connect each of them. Yes. And then we take pin. Then we align it with the first NOT gate. Then we take our second one and align it with the second one. Yes. Then we take one for each of the AND gates. We add a pin for each of the AND gates in alignment, in a nice alignment. Don't worry, this one I was just putting it together. I'll arrange it in a straight line very soon. But this is basically just the setup. So before we started, I mentioned in debugging, all of that. They will change our number inputs. Yes, we have to change the number inputs. That's very true. To 3. There's number inputs for the AND gates to 3 because we're only connecting 3. Yes. Initially, I mentioned we will have AND gates, OR gates, and NOT gates. Yes, and then see they are all present here. But then we are changing number of inputs to 3. Then we change the number of inputs for the OR gate. We change it to 4. Yes, 4. change it to 4. So we'll connect, then we start our connections. As I said before, I'll arrange it nicely and we'll connect. So now connecting. So now we'll connect our pin to our end gate. It's not straight, so let me straighten this one. Well, no, this is not working, so let me adjust it slightly to the bottom, and then draw my straight line that I'll connect it straight, connect my pin and my end gate. Yes, since there's a problem here, so I'll adjust it, and we're on the right track. Sorry. So then we continue, we connect all our gates. Oh shit, I went beyond. Yes. No, we'll still be connecting till we've had our full connections. Yes. And yes, still connecting. Right, so at this point we are done connecting the pins to the end gate. So we move on to connecting the OR gate to the rest of the end gates. Yes. So we join, and I'll move it up, and I'll join. Oh, since there's a problem, so yes, so I'll align it and I'll join, and yes, I have the clearance to go. I'll move down, and I'll join. Yes, I actually made a bit of a mistake here, so I'll clear and I'll redo it. I had to clear everything because it seemed I was off track, so I'll be clearing. Right, so I've rectified all the problems and rejoining my end gate to my OR gate. Yes, and I'll move downwards to the last end gate, and perfect. So at this point I'm going to join the rest of the end gates to the pins and then the NOT gate. So then the last end gate, the last pin on the last end gate will be joined further up to the first NOT gate. Yes. Then the second pin to the last end gate will be joined all the way to the second NOT gate connection. Yes. Then I move my third end gate. I'll join it to my connections here. At this point, then I will move this one and join it to the next connection to the last end gate first connection. Yes, so then this one I will move all the way and join it to the NOT gate. A bit of a problem here. Okay, yes, perfect. Then I will join these ones together. This one will go to the first connection on the first NOT gate. Yes, and I will join these ones. So I'll join all the way. Yes. So now I will simulate my work. So, and I will label each one, because remember in the introduction we get S0, S1, 10, 11, 12, 13 in that order. We name the pins and in that order. So 10, 11, 12, and 13. Okay. So I will simulate and take my first add pin, because I need to make an initial connection here. Yes, to this one. And now I'll simulate to my simulation. Oh, what am I doing here? Nope, this is not what. Yes, this is exactly what I wanted. Yeah, so you see as I simulate, the lines glow up and everything indicates that we're on the right track. Everything applies and everything is on the right track. Thank you very much for following me up to this point.